Hi. Leaf. Sugars. Hi, I'm Clare Burnett, and I'm here to shed some light on the light-dependent reactions of photosynthesis. Let's take a closer look, shall we?
Light-independent reactions of photosynthesis occurs in the lumen, or the intermembrane space, of thylakoids within the chloroplast. Light from the sun drives this reaction.
Fact! Did you know that plants have a favorite color too? Chloroplasts love red and blue light, which is why they absorb it, but they don't like green light, which is why they reflect it, causing plants to look green.
Light-independent reactions take place in photosystems within the lumen of the thylakoid. Pigments are organized in the lumen surrounding the photosystems. This reaction is a non-cyclical phosphorylation, also called an electron flow.
The purpose of photosynthesis is to create the components of glucose to later be processed in the Calvin cycle. But just like any omelet, you gotta crack a few eggs first. Let's see what's inside this omelet. Basil.
The internal inputs of this reaction are NADP+, H+, ADP, and phosphate. The external inputs are H2O and a light photon. The outputs of this reaction internally are ATP and NADPH, while the external outputs are O2.
A photon is absorbed by a pigment near photosystem 2 and is transferred to other pigments until it reaches the chlorophyll A molecule. The photon's energy excites the chlorophyll A molecule to a higher energy state.
Water molecules are split to produce 2 negative charged electrons, 2 positively charged hydrogens, and an oxygen. This process is called photolysis. These 2 negatively charged electrons are moved individually to the chlorophyll A molecule. The negative charged electron moves down an electron transport chain, being aided by PQ and PC. During this process, the electron loses energy. The lost energy drives chemiosmosis to bring about phosphorylation of ADP, resulting in ATP. Next, a light photon is absorbed by photosystem 1 and transferred through accessory pigments until it's received by a chlorophyll A molecule. The new electron now has a higher energy state and is transferred to the primary electron receptor. The electron from photosystem 2 fills the void from the transferred electron that left photosystem 1. The electron from photosystem 1 is passed down a second electron transfer chain that involves ferredoxin, which is also called FD. NADP plus reductase causes the transfer of the electron from ferredoxin to NADP plus, an energy carrier. 2 electrons are required to bond with NADP plus to form NADPH.
Thank you for coming on this little journey with me, and I hope you learned something about the green stuff. And I'm not talking about this green stuff. I'm talking about this green stuff. Photosynthesis and light-dependent reactions. See you next time!